Welcome everyone to week 2, muscle function. I know you look at those muscles and they can get awful overwhelming. The origins and assertions are important to understand. However, I'm not going to test you heavily on that. Just know that we all learn in layers, and as you get familiar with the muscles and the muscle function, it's important to know what bones they attach to, in other words, so they know what motions are going to create a functional movement pattern or a functional reaction. So here we are with the lower limb, and we're going to go over the calf. Okay, there's 4 compartments. You got the deep deep compartment, the superficial compartment, posterior compartment. You got the anterior compartment, and you got the lateral compartment. So start off with the deep superficial compartment, or deep posterior compartment, excuse me. You have the tibialis posterior and all the flexors of the toes, the flexor hallucis longus, the flexor digitorum longus, and the popliteus, and they all function right through here. What they do, they run down through the foot. Here's your foot. Run down through, and they circle on the inside of your foot, the inside of the malleoli, around the tibia, and they travel underneath the foot, and they hook into the bottom of the toes, and they flex the toes. The posterior tibialis comes down, very important muscle, comes off down through here and attaches right to the midfoot. Okay, we're not going to get into, it's in the manual where exactly they attach. It's not important at this point in time. Again, we're learning in layers. Just knowing the general motions of these muscles and what they essentially decelerate and concentrically accelerate. So as we go into the posterior, the superficial posterior compartment is your bigger muscles, the calf muscles that you see. So we have the gastroc, the soleus, and the plantaris. They come down to the back and hook right to the heel. Alright? So they come right down through and hook right here to the heel. The anterior compartment is your anterior tibialis and your toe extensors. Okay? So they come down in the front, they come in underneath the retinaculum and hook to the toes and extend. The extensor hallucis, the big toe. Hallucis is the big toe. Digitorum, extensor digitorum longus extends the other digits, the 4th through the 2nd through the 5th, sorry, toes. And the anterior tibialis comes through, and it crosses here, and it attaches right to the navicular here, and it actually helps pick up the arch. The lateral compartment, right on the sides, they're your perineals, okay? Fibularis muscle, but I call them perineals. Whatever you want to call them, alright? They travel down through, and they come behind the lateral malleoli, okay, of the fibula, and one attaches right along the 5th metatarsal, the brevis, and the longus comes underneath between the cuboid and the calcaneus, and it attaches very close to the posterior tibialis, right to the first ray, and that helps stabilize your midfoot and this big toe right here. Very important. We'll cover that a little bit more specifically when we get into short foot, probably in the seminar. So they're the calf muscles. All right, so we can memorize those. We can understand and where they all attach. That's great. Layers. You're not going to be tested on this. However, what you are going to be, what I expect you to understand is what they do functionally. So, just put it this way, the posterior muscles, both deep compartment and superficial compartment, decelerate in the sagittal plane dorsiflexion. So as the shin or the tibia goes over a fixed foot, so the foot's on the ground, and your foot goes forward, or your shin goes forward, your knee bends, then those muscles back there get essentially lengthened, and they decelerate decelerate dorsiflexion actually, or anterior tibial movement, but it is dorsiflexion. That's the sagittal plane. In the transverse plane, they actually decelerate torsion, tibial internal rotation. So as the foot hits the ground, there's the pronation that goes on, and the tibia internally rotates. We don't want it to internally rotate too much, because our knee will be on the inside of our foot, which is very bad. We want to have it rotate just as much so we can decelerate that motion. So again, transverse plane deceleration. There's stuff that goes on the foot also in the transverse plane, but that's a higher level, something that we don't need to cover right now. Okay, those muscles do have function because the deep superficial muscles do attach underneath the foot, so they're going to decelerate all these bones right in the foot. Okay, we're not going to be caught up with that quite yet. So as you go through dorsiflexion, there's an internal rotation. This is front foot stepping forward. In the frontal plane, these muscles that travel behind the malleoli of the tibia here, the medial malleoli, and the muscles that come down attached to the calcaneus, they help decelerate calcaneal eversion. So that's when the foot hits the ground, you go through pronation, that calcaneus everts. It tilts outward, if you will, but it rolls in. The muscles here have to decelerate this motion, so it kind of, if you can picture the muscles here and the muscles on the calcaneus, as that calcaneus goes in, or your foot rolls into pronation, it has to decelerate that. It has to control that motion, because if it doesn't control the motion, you overpronate and the tibia internally rotates. So you have hyperpronation, and that will affect your kinetic chain, especially the knee. Okay, when we get into joint-by-joint theory, you'll understand that a little bit more. The lateral compartment, the perineals, they come through behind the lateral malleoli, hook to the bottom of the foot. They actually decelerate dorsiflexion, so the same. So you can see all these calf muscles decelerate dorsiflexion or tibial movement. They also, on the back leg, as we go through and we come out of extension, the foot supinates. So the tibia externally rotates. Well, the perineals actually decelerate that motion. Okay, they decelerate that motion. When your foot supinates, that, in other words, back foot, the calcaneus goes from here to a supinated position. So if you can picture those perineals coming down through here, they decelerate that overpronation. Just like when we sprain our ankle, we turn our foot out. That's an inversion sprain. Okay, that will affect the ligaments. Well, these muscles here are the dynamic stabilizers. The perineals are the dynamic stabilizers of that lateral ankle. So it's very important to have those strong so they know proprioceptively where the ankle joint position is, so they can contract and they can control that motion as much as it needs to be. The front part, the interior muscles, are the muscle, the toe extension, pretty straightforward. They actually decelerate plantar flexion. So as we're walking, we hit, and that foot goes through. They decelerate it, and then they concentrally bring it back up into the dorsiflexion. That's the sagittal plane. Internal rotation. That anterior tibialis, as they internally rotate and go through pronation, the foot falls, the arch collapses. Well, that anterior tibialis in the transverse plane decelerates that drop of the navicular. However, we're going through dorsiflexion, so it's actually in a relaxed state here. So we can have, it's called econcentric. There's a term for it. We won't get much in that because it's very confusing. In one plane, the muscle can be in its shortened state. In another plane, it can actually work, in this case the transverse plane, it can actually work in through deceleration. So it has to control those bones even when it's in a shortened state and a lengthened state. Kind of a confusing thing. We'll clear that up if there's more questions. You won't be tested on that, so no need to worry about that. So that's the calf musculature. That's what's important to understand is deceleration of dorsiflexion, deceleration of plantar flexion, deceleration of internal rotation of the tibia, external rotation of the tibia, deceleration of calcaneal eversion, calcaneal inversion, or full foot pronation, or rear foot pronation, supination. They're all mechanics. As you go through gait, we heel strike, we go through pronation and tibial internal rotation and dorsiflexion, and as the back leg's behind us, we go through supination, tibial external rotation, and that allows us to propel. And then, of course, that feeds the proper information up to the hip into the kinetic chain, the biomechanics of it. All right, we'll be talking about more muscles. Stay tuned. Thank you.